So we are studying chapter number 13, solution and its properties. So one property is the physical change. For this topic of this slide is this: dissolution is a physical change. What is the meaning of physical change? For an example, if we dissolve, dissolution is a physical change means you can get back the original solute by evaporating the solvent. So for an example, if you are adding sodium chloride salt into water, and if you will remove water out by evaporation, you will get the sodium chloride back. So that process is called physical change. But if you cannot get the reactant or substance back, then it could be dissolved. That will be a chemical change. For an example, if we add sodium metal into water, it forms sodium hydroxide. We cannot get back sodium metal. So that will be chemical change. Another important property of the solution is called miscible or soluble versus immiscible or insoluble. So miscible means soluble compound have a solubility at every concentration. What is the miscibility or solubility? So any solute have the solubility at every concentration, that is called miscible or soluble. And immiscible or insoluble means compound have a solubility less than 0.01 mole per liter. So here in the two examples are shown that if water and methylene chloride, so here you can see these two layers are separated to each other, they are immiscible. But here when you add water and acetone, they are mixed together. In this case, if you are adding oil or some other immiscible liquid into water, they are not mixing together. So this shows the immiscible part. This is immiscible, this is miscible. So next property of the type of the solution is called saturated and unsaturated solution. What is the meaning of these word? So suppose you can add 1 teaspoon of sugar into water, half a glass of water, and it dissolve, and you can add further 1 teaspoon and dissolve sugar, then the solution will be unsaturated, means it can dissolve more and more. So by that time it's called unsaturated. But if you are adding 4th teaspoon and after once you add 5th teaspoon of sugar into the glass of water, it did not dissolve, it settled down. So this solution will be saturated solution. It means it reaches its maximum solubility, right? So there are terms which are called unsaturated, means less than the maximum amount of solute is dissolved in the solvent, and saturated means the maximum amount of the solute is dissolved in the solvent, and supersaturated. So suppose if you heat this solution after adding 5th or 6th teaspoon of sugar into water, if you will heat this one, it can dissolve, you can dissolve more and more, and you can add more sugar, it will become more and more concentrated. You can continuously heating and dissolve, you can keep dissolving, and at the end basically you are making a supersaturated solution. So more than the maximum amount of solute is dissolved in the solvent. So good example is the candy or hard rock candy. So they are example of supersaturated solution where there is a lot of sugar is involved in a less amount of the water. Another example you can understand through this YouTube video, is link is here. So if you have, this is a beaker, shows that seed crystal of ammonium acetate. So in this beaker ammonium acetate was added, and you can see in the water this is a saturated solution, and as you will add one extra particle of the ammonium acetate, sodium acetate, this is sodium acetate, as you will add sodium acetate, it will start crystallizing. So this solution is called supersaturated when both the solute and solvent are in dissolve condition, they are in homogeneous condition. As you will add one more extra crystal of sodium acetate, it will start precipitating or it will start crystallizing. So then this is called like a supersaturated solution. So this stage is a supersaturated solution once it convert back into the crystals. So what is the definition of solubility? Solubility is the definition that maximum amount of solute, either it could be in the gram quantities or kilogram quantities or mole quantities, that can dissolve in a given amount of solvent. It would be gram, liter, ml, any unit at a specific temperature. So temperature is very important. So at certain temperature, ammonium, this sodium acetate is completely dissolved in this solution, and but if you are changing temperature, this proportion will change. So this was about the solubility, and let's see next topic in this solubility, that there is a quotation that is called like dissolve like. Like dissolve like means that polar and ionic molecules tend to dissolve in polar solvent. So any polar molecule or any ionic molecule always dissolve in a polar solvent, and non-polar molecules tend to dissolve in non-polar solvent. What does it means? It means that if like methanol or ethanol, they are polar molecules, they can dissolve in the water. Water is considered as a polar. But non-polar molecules, suppose such as fat, oil, that cannot be dissolved in water. They will dissolve like a gas, hexane, or petrol, that can dissolve only in the oil. So non-polar compound dissolve in non-polar solvent, and polar compound dissolve into polar solvent. Next thing is this, how the molecular structure affect about our the solubility. For an example, cyclohexane versus glucose. So this is a structure of cyclohexane where each corner represent the carbon. So 1 2 3 4 5 6. So there are 6 carbon in this 1 2 3 4 5 6. 6 carbons are there, and total 12 hydrogens are there. So this structure you can also draw like this one, that one hexagon. So this is a kind of highly non-polar compound, and glucose have hydroxyl group, OH group. So OH groups are considered as a polar group, and that can form hydrogen bonding. So if molecule have polar group, it will dissolve in the polar solvent. So this glucose is freely dissolved in water, it will be through hydrogen bonding. But cyclohexane cannot dissolve in the water, it will dissolve only in the non-polar solvent. So another example of the solubility and molecular structure is if we have a long chain of molecule versus short chain. For an example, this is a vitamin D. Vitamin D have a long chain of non-polar molecule, and at the end we have very small polar group, which is OH group. So non-polar and polar. And vitamin C have more than one polar group, OH group, OH group, OH group, OH group. So this is 4 OH group are involved. So this will be more soluble compared to this one. So more polar group will help in the solubility. So let's see one example in this case. Which one of the following compound will be compound will mostly be dissolved in water? So you can think about, for this question, methanol, ether, methyl chloride, and carbon tetrachloride, which compound will be dissolved more in the water? So you have to remember that solubility rule, like dissolve like, and you can find out which compound is more water soluble or polar, that will dissolve into. So we will see in the next slide, next video, some other effect on the solubility.